The gradient, divergence, and curl in spherical coordinates. So we're going to start out with writing the position vector in Cartesian coordinates again. It's xi hat plus yj hat plus zk hat. Now the coordinates transformation equations, we have x given by r sine theta cosine phi in I hat direction, and we have r sine theta sine phi in j hat direction, and finally we have for the z component r cosine theta. So these are the coordinates and position vector in spherical coordinates when we use the transformations from spherical to Cartesian coordinates. Now, in order to get the scale factors here, I have to take a derivative of the position vector with respect to r and take its magnitude. Now, r is present in each term, so I will have sine theta cosine phi, sine theta sine phi, and cosine theta. So I have to take the magnitude of sine theta cosine phi in I hat direction and plus sine theta sine phi in j hat direction, and then I have plus cosine theta in k hat direction. So in the magnitude, I will have square root of x squared plus y squared plus z squared. So that means I'm going to have sine square theta and cosine square phi plus sine square theta sine square phi, and then I have cosine square theta all inside the square root. So this is going to give me the magnitude. And as for the sine square theta parentheses, I would have sine square theta parentheses. I have, you can see here, sine square phi and cosine square phi. So sine square phi plus cosine square phi plus cosine square theta all inside the square root, and this sine square phi plus cosine square phi is equal to 1, and then I will have square root of sine square theta plus cosine square, which is also 1. Therefore my answer is 1 for the scale factor for the r. And for theta, I'm going to take a derivative with respect to theta. So the theta derivative will affect this term. It will give me r cosine theta cosine phi. It will give me r cosine theta sine phi and minus r sine theta in k hat direction. So the magnitude of del r del theta, that is r cosine theta cosine phi in I hat direction plus r cosine theta sine phi in j hat direction, and then I have minus r sine theta in k hat direction, and we're taking its magnitude. So we're going to end up with, because r is common to all of these terms, r comes outside, cosine square theta parentheses, cosine square theta parentheses, cosine square phi plus sine square phi, and the last term is sine square theta, all inside the square root, and this is 1 again, so we obtain square root of cosine square plus sine square, which is also 1. Therefore, my answer is simply equal to r. For the third scale factor, h phi, I have to take a derivative with respect to phi. That won't affect this one, there's no phi here. It will affect this one, minus r sine theta sine phi, and plus r sine theta cosine phi will be the derivative. So let me work on that. Here I have magnitude of minus r sine theta sine phi in I hat direction, and plus r sine theta cosine phi in j hat direction. And that will give me, because r sine theta is common to all the terms here, it will give me r sine theta parentheses square root of sine square phi plus cosine square phi, which is 1. Therefore, the answer is r sine theta for this scale factor. Now we can apply the gradient formula here, qi hat over hi del qi. So the gradient will be del phi for the scalar function phi here, scalar field, del phi del r in qr hat direction, so 1 over hr, which is 1. 1 over h theta, that's 1 over r, plus 1 over r del phi del theta in q theta hat direction. And then we have 1 over r sine theta, 1 over r sine theta del phi in q phi hat direction. So this is our gradient operation. As for the divergence, we have 1 over hi hj hk del qi hj hk times ai. So if I take the product of the scale factors, one of them is 1, the other one is r, the other one is r sine theta. Therefore, I will obtain 1 over r square sine theta. And then I have partial derivative of, so I'm taking the derivative with respect to r, so I should talk about theta and phi. H theta and h phi, it's r square sine theta a sub r del r plus, now I'm talking about the theta derivative, which means I should use hr and h5, so that's going to be r sine theta here. So I have 1 over r square sine theta, and as for the derivative, I'm taking the derivative of r sine theta a theta with respect to theta. And for the last term, again, I have 1 over r squared sine theta. This time I have hr and h theta, which means this is r times a phi, derivative with respect to phi. All right. Now you can see for the first term, I'm taking an r derivative, but there is a sine theta here and sine theta here, so they will cancel out. For the second term, I'm taking a theta derivative, so r is unaffected, so r's will cancel out. And for the last term, I'm taking a phi derivative, again, r's will cancel out. So my final answer for divergence of A written in spherical coordinates is 1 over r squared del r squared ar del r plus 1 over r sine theta del r squared ar, so del sine theta a theta with respect to theta. And for the last term, 1 over r sine theta del a phi del phi. So this gives us our final answer for the divergence in spherical coordinates. Now let's work on the curl in spherical coordinates. Once again, we have this previous result, so we have to take this determinant, 1 over h1, h2, h3, which is 1 over r squared sine theta in this case, r squared sine theta. Now we're taking the determinant. The first row is qr hat, hr qr hat, h theta q theta hat, and then h phi q phi hat, del r, del theta, del phi. We have hr ar, h theta a theta, and h phi a phi. So this determinant is the answer to the curl written in spherical coordinates. So we can start with, we can do this with respect to the first row and start with qr hat component. So we have del theta r sine theta a phi minus del phi r a theta, 1 over r squared sine theta in qr hat direction. So we have 1 over r squared sine theta first we're taking the derivative of with respect to theta of r sine theta a phi, so del r sine theta a phi with respect to theta, del del theta, minus del, the second term is del del phi of Ra theta, Ra theta del del phi. This is in QR hat direction. Let's move this up a bit. All right. And as for the second term here, I have minus r q theta hat times r square sine theta, 1 over r square sine theta. So this will give me plus 1 over r sine theta. Because of the minus sign here, first I'm going to take this derivative, del AR del phi minus the second term, del del r sine theta a phi. Del r sine theta a phi with respect to r. This is in q theta hat direction. And for the last one, I have del del r Ra theta minus del del theta AR. And because of the r sine theta here, I'm going to get 1 over r. So this is plus 1 over r del r a theta del r minus del AR del theta. So del r of Ra theta minus del del theta of AR in q phi hat direction. Okay, now we can put it together. For the first term here, we have theta and phi derivatives, and we have r's inside, so those r's will cancel out with the r at the in the prefactor here. So this r will get rid of this r and this r. For the derivative here that includes r sine theta with respect to r, the sine theta term is not a function of r, so that will cancel out with this one. So let me note that here this sine theta term will cancel out with this sine theta term. And for the last one, this is an r derivative, so there's nothing I can do here. So that will remain the same. Now we can write the final answer. 1 over r sine theta del sine theta a phi del theta minus del a theta del phi qr hat. 1 over r, then we will have 1 over sine theta here, del ar del phi minus del r a phi del r, and then this term remains the same. So let's write the final answer, final simplified answer here. We have 1 over r sine theta del sine theta a phi del theta minus del a theta del phi this will be in QR hat direction. Then we have plus 1 over r, parentheses, 1 over sine theta del AR del phi minus del R A phi del R. Remember, sine theta was cancelled out for this term. So we have Q theta hat. And then we have plus 1 over R again. Del R A theta del R minus del AR del theta, and this is in Q phi hat direction. So this will be our final answer for the curl of A written in spherical coordinates. So once again, we have gone through this same exercise. First, we start with the position vector written in terms of theta, phi, and r. Take a derivative with respect to r and magnitude, hr is 1. Take a derivative with respect to theta magnitude, h theta is r. Take a derivative with respect to phi magnitude, h phi is r sine theta. 1 over hr is 1, qr hat del phi del r. 1 over h theta is r, del phi del theta q theta hat. 1 over h phi, which is 1 over r sine theta, del phi is q phi hat, multiplied by q phi hat. This gives us the gradient. The divergence is 1 over hi, hj, hk. So 1 over r sine theta r1, that is 1 over r squared sine theta, del h theta h phi, which is r squared sine theta ar del r, plus 1 over r squared sine theta del h r h phi. hr is 1, h phi is r sine theta, a theta with respect to theta, plus 1 over r squared sine theta del h r h theta, which is 1 times r divided by del phi. So this, with the simplifications, we get our divergence. And for the curl, we take this determinant now. The first row is qr hat, qr hat, hr is 1. H theta, q theta hat, h theta is r. H phi, q phi hat, h phi is r sine theta. And the partial derivatives, and for the last row, hr, ar, that's ar. H theta, a theta, that's r a theta. And h phi, a phi, that's r sine theta, a phi. Also being careful with this minus sign here. After the simplifications, I obtained this final result for the curl in spherical coordinates.